Okay, so last class we talked about exponential functions, and we talked specifically about exponential growth and exponential decay functions, where the growth was y equals a times the quantity of 1 plus r times time to the exponent of time. And then we talked about decay as well, where it's the same thing, but instead of a plus r, it's a minus r. What I wanted you to observe, though, is that really that's the same thing as these exponential functions we've been doing the whole time. You know, y equals ab to the x power. The only difference is that the b is a 1 plus r on the exponential growth, and the b is a 1 minus r on the exponential decay. And of course, instead of an x, they're calling it a t, but it's the same thing. It's the same format. You're just adding 1 or subtracting or minusing from 1 to the decay. So it's really the same idea of what we've been doing the whole time when you do these exponential growth and decay. Oh yes. Also, just remember that the y is going to be your end result, the output, the final amount. The a is the amount you're starting with, and the minus r or the plus r is called, in this case, the decay factor, or if it's a plus, it's called the growth factor, and the t just stands for the amount of time. This is all review of what we covered last class. Oh, we have a message here. Cool. Okay, so moving along, I would like to actually do some application with these things. I would like us to be able to interpret and rewrite exponential functions given this idea that we just covered, okay? So let's look at this one here. And what I want you to discover and tell me is this an exponential growth or an exponential decay? Looking at it. See how it's in the same format, y equals, the a is a 5, they have the parentheses, this is the 1 plus r, and this is the t. But is it a plus r or is it a minus r? Well, how do you answer this question? One thing you could do is see that it's actually more than 1. It is more than 1, right? Is greater than 1. It's 1.07. And so if it's more than 1, it must be 1 plus something, not 1 minus something, right? Because it's more than 1, so you know that it's exponential growth. But how much, though? There's a couple ways you could answer this, but I just like to do it algebraically. It just makes sense to me. In other words, if I were to do it algebraically, this 1 plus r, this growth factor, right down here, 1 plus r, would equal what's in there, the 1.07. Now, all I have to do, now let's set up as an equation, is solve for r. And since r is being added to, I do the inverse operation, which is to subtract, or 1 from both sides. These cancel out, and the r would equal 0.07. So that's what the r was when this question was asked. The r was a 0.07. We just had to do it backwards, do inverse operations to see what it was. So so this case, it was an exponential growth with the rate being a 0.17, and that's how we did that. Let's see if we can do another problem here. Let's see, do I have another one? Yeah. Let's do this one right here. Flip this page over. And this one says f of t, which just means the function of time. I could put a y there, is 0.2 times 0.98 to the t. So, again, is this going to be an exponential growth or an exponential decay? Well, to me, I can tell it's a decay because it's under 1. It's not quite 1, it's 98. So you must have took something away from it. It must be y minus something. So we know it's decay. In order to find out what it is, we just have to set it up algebraically. So we know this, 1 minus 1, the decay rate, is going to equal this. So we know it's decay, but what is 1 minus r equals 0.98. And how would we solve it algebraically? Well, we have to solve for r. There's a couple ways you could do it. Well, let's do it this way this time. I'll add an r to both sides. I don't usually do it this way. I usually get rid of the 1 first, but just to show you, there's more than one way to do this. Then I'll subtract a 0.98 from both sides. And these cancel out. You bring down the r. That'd be 0.2. So the r was originally a 0.02. 0.02. I can get it out. There we go. So I would like you to go ahead and try one. See how you do on it. See if you can get it right. So it's your turn. So give this one a shot. Give this one a spin. See, first of all, answer is an exponential growth or decay, and then by how much? Okay, now there's this other sort of problem, one that looks sort of like this. And the question I would ask, what do you do if it's like something like a t over 4? How would you solve that? What would you do? So looking at this one here, remember that if it's in the denominator, you could also write it in radical form, right? And that's the root. And the t would be the power. So it'd be 0.96. So basically, what 4 numbers can you multiply together to get 0.96? What times what times what times what is 0.96? And if you want, you can always pull out your phone, right? You do it, and if you have a scientific calculator, you can either push the caret symbol. On my case, I'll do 4th root of 0.96, and it equals, oops, sorry, mistake. So I'm getting 0.99. 0.99. Roughly.